Hello everyone, Tom from EveryStepCalculus.com, EveryStepPhysics.com. A line integral problem regarding a right angled curve. And let's do it. Index 8 to get to my menu. I'm already at line integrals, save time on the video. And I'm already at right angled curve, which you choose in the next menu. We're going to enter our vertices. You have to press alpha before you enter anything in these entry lines here. And the first vertex is minus 4, 1. Alpha minus 4 alpha 1. Second vertex is minus 4, minus 2. Alpha minus 4 alpha minus 2. Third vertex is 2 and minus 2. Alpha 2 alpha minus 2. I go slow because the simulator sometimes screws up if you go too fast. So, but notice the vertices are elementary numbers, and so shows you that it's all contrived setup nonsense to waste our time learning it. That's why you have a program. You don't have to learn it. You have to just want to pass the test or get your homework done quick and get onto something more important and more useful in life, in your degree. So I always show you what you've entered. You can change it if you want. The first line segment is from minus 4, 1 to minus 4, minus 2, etc. Minus 4, minus 2 to 2, 2, minus 2. And now we're going to parameterize the whole situation. I know you know how to do this. You don't need any help on this. Not really. I needed a lot of help on it. And you have x of t. You're parameterizing it with respect to t. And so you take the first x minus the second x in your segment, and that comes up to 0. And then you get yt. You've taken the first y minus, or the second y minus the first y, and you come up with minus 3t here. Take the derivative of that. Well, you got to first find the formula. Minus 4 and 0t and 1 and minus 3. Derivatives of that is 0 and minus 3. We're going to enter the function. And we're going to enter what's before the dx on these problems. The only way I can figure out how to do it. And before the dx is alpha y cubed, and enter the function before the dy characters, and that would be x cubed, alpha x cubed. And then you notice whether it's a plus dx plus dy or dx minus dy. It's a plus in your problem. And so I show you again what you've entered, and you can check it. We haven't entered the limits yet from a to b, but we will. I say it's okay. The limits for segment 1 are 1 to minus 2. And we add the parameters to the function. Notice for y and x, here they are here. You'll put parentheses where you see the quotations here in your test paper or homework. And just like you see it on the screen here. And now we have the limits in your minus 2. We have them multiplied times together. And we get this new integral here, integral 192 dt, we integrate it, we get 192t, of course, and minus 2 and minus 1 for limits. T at minus 2 is 384. T at 1 is 192. Those add up to minus 576. Segment 2. Here's the segment 2. You got to do all this x of t, and we're adding the parameters again. And x and y formulas, and then the derivatives of that. Limits are from minus 4 to 2. We set up the integral, and adding the parameters to the y and x values of the original function, and go through the problem. You can pause this and quickly, if you're looking at it, to write down everything you want to see. And we integrated for minus 48t over 2 and minus 4. At 2 it's minus 96, at minus 4 it's now 192, upper minus lower, and then we add the two segments together, come up with minus 864, total of the two line segments. Pretty neat, huh? Try this by memory sometime if you want to try it. Everystepcalculus.com. Think about going to my site and buying my programs and passing your calculus and making it much easier to learn this nonsense. Have a good one.